At 11:47 p.m., in the ink-black waters of the northern Arabian Sea, 260 miles southwest of the Pakistani coastline, the USS Abraham Lincoln was making 22 knots into a light headwind. The flight deck was dark. The catapults were cold. The ship's company of 5,200 men and women were distributed across 3 shifts: those on watch, those sleeping, and those in the narrow, exhausted space between the two. At this hour, in this sea state, a carrier strike group at sustained transit speed produces a particular quality of sound: the deep, subsonic vibration of 4 shaft-driven propellers turning 130,000 tons of American naval engineering through salt water, overlaid with the constant white noise of ventilation systems and the periodic clang of material moving through interior passageways. It is a sound that becomes invisible to those who live inside it. Background, texture, the rhythm of operational life at sea. At 11:47 p.m., 13 launch signatures appeared simultaneously on the threat display inside the Combat Information Center of the guided missile cruiser USS Leyte Gulf, positioned 4 miles off the carrier's port bow. The operator who first called it did so in a voice that was quieter than anyone in the compartment expected. Not from composure, but from the strange physical compression that accompanies the recognition that a thing you have trained for 10,000 times has, without announcement, become real. 13 ballistic missile launches. Origin points distributed across 3 separate sites in Iran's southern Khuzestan province and along the elevated terrain north of Bandar Abbas. Trajectory analysis completed in 4 seconds. Target solution: the carrier strike group. Time of flight to engagement range, 11 minutes, 20 seconds. The IRGC Aerospace Force had spent 4 years building toward this moment. The weapon they had chosen was the Khalij Fars family of anti-ship ballistic missiles. Iranian-developed, terminally guided, designed from inception to defeat the layered air defense architecture of an American carrier strike group by combining ballistic re-entry profiles with a terminal maneuvering phase that traditional missile defense geometries struggle to engage. They had launched 13 of them. In the doctrine they had developed, modeled, and rehearsed across 17 tabletop exercises and 3 live-fire drills using surrogate target vessels, 13 simultaneous arrivals from separated azimuth angles was the calculated saturation threshold above which American intercept capacity would be exhausted. 1 or 2 would get through. 1 impact on a carrier deck was a strategic statement. 1 impact on a carrier's island superstructure was, potentially, a generational event in the history of naval warfare. The calculations were sound. The doctrine was coherent. The execution was precise. And the fundamental premise on which every single one of those calculations rested was wrong. The premise was this: that the Americans had not seen them coming. Space Force Strategic Missile Warning had flagged elevated thermal activity at the Khuzestan launch sites 72 minutes before ignition. The signature was not a launch, not yet. It was the thermal bloom of liquid-fueled missiles being brought to readiness. Propellant loading, pressurization. The infrared signature of rocket fuel meeting oxidizer in a missile's fuel system is distinctive in a way that trained analysts recognize immediately, and the satellite asset that registered those signatures was not operated by a junior analyst on a first deployment. The warning reached CENTCOM at 10:35 p.m. The carrier strike group had been at modified condition 3 since 10:41 p.m. Every air defense system in the group had been brought to full active emission. The Aegis combat system aboard the Leyte Gulf and the 3 Arleigh Burke-class destroyers positioned in the strike group's outer screen, USS Gravely, USS Mason, and USS Forrest Sherman, had been running continuous tracking on the launch sites, their Spy 6 and Spy 1 radars painting the terrain with energy, waiting. When the 13 missiles left their launchers at 11:47 p.m., the Aegis combat system had already built preliminary intercept solutions on every one of them before they cleared their launch rails. The Combat Information Center of the Leyte Gulf in the seconds after detection was the controlled chaos of a system performing exactly as designed, which is to say, very fast, very loud, and with a precision that looks, from the outside, like calm. It is not calm. It is trained urgency channeled through procedure. The tactical action officer's voice was steady because steadiness is a professional requirement, not because there was nothing to fear. The threat display showed 13 tracks climbing the atmosphere on ballistic arcs, their projected impact points clustering around a 2-mile radius centered on the Lincoln's last known position. The system updated the intercept geometry every 100 milliseconds. Firing solutions were queued. The Standard Missile 3 Block IIA interceptors in the Leyte Gulf's forward vertical launch system cells were the primary engagement weapon, a 67-inch diameter, 18-foot-long kinetic kill vehicle designed to intercept ballistic missiles in the exo-atmospheric mid-course phase above the atmosphere, where the thermal environment is clean and the engagement geometry is optimal. The first salvo of SM-3 Block IIA missiles left the Leyte Gulf's VLS cells at 11:49 p.m., 2 minutes after the initial detection. 4 missiles in 12 seconds, their booster stages lighting the surrounding ocean in a blue-white torch that was visible on the bridge of every vessel in the strike group and, according to one report, later filed by a commercial vessel 30 miles to the south, from the deck of a container ship whose crew had no idea what they were witnessing. The missiles climbed at 45 degrees, then adjusted, then climbed again, their onboard seekers reaching out for the heat of Iranian rocket exhaust against the cold black of the upper atmosphere. 300 miles overhead, a Space Force tracking satellite confirmed acquisition handoff between the ship's radar and the interceptor's onboard seeker at 11:50 p.m. and 12 seconds. The first 2 intercepts occurred at 11:51 p.m. at an altitude of 81 miles above the Earth's surface. 2 Khalij Fars missiles ceased to exist as functional weapons at the same moment, their kinetic energy converted into an expanding cloud of debris above the Kármán line. The debris field was not a concern. At that altitude, fragments re-enter and ablate. The concern was the 11 that remained. The destroyers were already shooting. The USS Gravely, positioned at the northern apex of the strike group's defensive screen, contributed 4 SM-3 launches of its own between 11:49 p.m. and 11:51 p.m. The USS Mason, running 22 miles to the southeast, added 3 more. The USS Forrest Sherman, which had repositioned 16 hours earlier to cover a specific azimuth gap in the group's defensive geometry, a decision made by a destroyer commanding officer who had studied the IRGC's anti-ship ballistic missile doctrine for 8 months, was tracking the 4 missiles coming from the Bandar Abbas area launch sites on a trajectory that brought them in from the south-southwest, the angle that gave them the best terminal geometry against the carrier's flight deck. The Forrest Sherman's tactical action officer fired 5 SM-3s in 9 seconds. All 5 acquired. 3 intercepts were confirmed in the midcourse phase. The remaining 2 Bandar Abbas trajectory missiles survived into the upper atmosphere and began their terminal dive. This is where the doctrine diverged most sharply from the IRGC's calculations. The Khalij Fars terminal maneuver, the feature that gave the weapon its theoretical ability to defeat standard intercept geometries, was designed to defeat the standard Missile 2 family of interceptors, which engage in the terminal phase at lower altitude with less maneuvering margin. What the IRGC's 4 years of doctrine development had not adequately accounted for was the integration of the terminal high-altitude area defense battery embarked on the auxiliary vessel operating 12 miles west of the carrier. THAAD does not engage in the exo-atmospheric midcourse phase. THAAD waits. It waits in the upper terminal phase, inside the atmosphere but at altitude, where its hit-to-kill interceptor can still engage a maneuvering target before it reaches the flat, fast, low-altitude regime where intercept probability collapses. The two surviving Bandar Abbas trajectory missiles began their terminal maneuver sequence at 11:53 p.m. at an altitude of 40 miles. The THAAD battery engaged at 11:53 p.m. and 18 seconds. Both missiles were neutralized at 31 miles altitude, their terminal guidance systems shredded by kinetic impactors traveling at more than a mile per second. The count at 11:53 p.m. and 22 seconds was 11 intercepts confirmed. 2 missiles remained in flight. These two, launched from the Khuzestan sites on a longer-range trajectory, had taken a slightly different flight path, a higher apogee that extended their time of flight and brought them into the terminal phase from a northern azimuth, while the bulk of the defensive engagement was oriented south and southwest. This was deliberate. It was the desperation move built into the IRGC's saturation doctrine. The azimuth split was designed to force the Aegis ships to divide their engagement priorities and create a window in the handoff sequence. In the tabletop exercises, this window was 7 seconds. 7 seconds during which 2 missiles on a northern terminal trajectory would have no active interceptor assigned. The USS Gravely's tactical action officer had studied this exact scenario. She had studied it because the IRGC's anti-ship ballistic missile doctrine had been publicly discussed in enough detail, in think tank publications, in defense journals, in translated IRGC training materials, that a sufficiently motivated analyst could reconstruct the saturation logic from open sources. She had held back 2 SM-3s from the initial salvo for exactly this contingency. She fired them at 11:52 p.m. and 40 seconds, before the 7-second window opened, giving the interceptors enough flight time to acquire the northern azimuth threats in their midcourse phase. The first intercept was confirmed at 11:53 p.m. and 51 seconds. The second at 11:54 p.m. and 3 seconds. 13 missiles launched. 13 missiles neutralized, 0 impacts. The mathematics of the engagement were unambiguous and would be dissected in defense journals for years. The IRGC Aerospace Force had constructed a saturation model based on accurate data points, the number of VLS cells in a carrier strike group's defensive screen, the reload time of those cells, the engagement capacity of each Aegis ship, against a simultaneous multi-axis threat. The model was technically competent. What it could not account for was the distributed engagement authority that allows multiple Aegis ships to coordinate intercept assignments without voice communication, deconflicting their fires automatically through the cooperative engagement capability data link that connects every ship in the formation into a single tactical picture. The IRGC's saturation threshold assumed each ship was fighting independently, its capacity constrained by its own sensors and its own fire control. In reality, every ship in the formation was drawing on the sensor picture of every other ship simultaneously. The USS Gravely held back 2 SM-3s, not because her sensors had detected the azimuth split, they had, but because the CEC picture showed that the Lady Gulf and Mason had the southern and western threat arcs covered with margin to spare, and the tactical action officer had read the IRGC's doctrine well enough to know that the azimuth split was coming. She had the shot. She waited. She was right. The carrier strike group had not stopped moving. It had not stopped conducting operations. In the Combat Information Center of the Lady Gulf, the tactical action officer completed the engagement log entry, handed the watch to her relief, and walked to the coffee station at the back of the compartment. Her hands were not shaking. They had been briefly around 11:52 p.m. during the 17 seconds when the azimuth split threat was developing, and the intercept solution on the 2 northern trajectory missiles had not yet been confirmed. She had not mentioned it then. She did not mention it now. It was not relevant to the log, but the engagement was not over. An intercept is a defensive act. The response was already airborne. At 11:41 p.m., 6 minutes before the IRGC launched, while the thermal signature of propellant loading was still being analyzed, the Lincoln had begun launching aircraft. not a strike package. A combat air patrol surge positioning F/A-18E and F/A-18F Super Hornets at altitude with full air-to-ground loadouts, co-located with tanker support in a holding pattern over the northern Arabian Sea. The Strike Package Authority had been pre-delegated under a contingency order signed 48 hours earlier. The targeting package for the 3 IRGC Aerospace Force launch sites had been updated in real time through the engagement. Bomb damage assessment on the launch sites, now confirmed active, now confirmed hostile, had been transmitted to the strike package lead at 11:52 p.m., while the last 2 Khalij Fars missiles were still in their terminal dive. The strike lead acknowledged at 11:53 p.m. and 15 seconds. He turned his aircraft northeast. The rest of the package followed. The EA-18G Growlers went in first, as they always do. 3 of them, their jamming suites configured for the specific radar and communications frequencies used by the IRGC Aerospace Force's integrated air defense network across the southern launch corridor. The Growlers did not jam everything. Jamming everything is crude. What the Growlers did was more precise. They created specific, targeted interference in the frequency bands used by the surface-to-air missile batteries defending the launch sites, preventing those batteries from receiving coherent targeting data from their associated acquisition radars. The radar could see. The missile battery could not receive what the radar was seeing. The operational result was identical to blindness, achieved without alerting the radar operators that they had been blinded. From their perspective, it was simply noise. An unusually bad night for signal quality. The HARM missiles addressed the radars themselves 4 minutes later. 6 AGM-88E, advanced anti-radiation missiles, launched from 2 Super Hornets at the outer edge of the engagement envelope, homed on the electromagnetic emissions of the SA-15 Gauntlet batteries surrounding the northernmost Khuzestan launch site. The SA-15 is a capable, highly mobile short-range air defense system. It is not capable of defending against a weapon that travels at Mach 2.5 and homes on the radar the system uses to detect threats. The 2 batteries guarding the northern site were rendered inoperable at 12:03 a.m. The single battery protecting the central Khuzestan site went dark at 12:04 a.m. The Bandar Abbas area site, more heavily defended, had 3 batteries, 2 SA-15S and 1 aging SA-6. The SA-6 attempted to engage the incoming HARM at 12:04 a.m. and 40 seconds. The engagement failed. The SA-6 battery was rendered inoperable at 12:05 a.m. The 2 SA-15 batteries at the Bandar Abbas site lost their acquisition radar links to Growler jamming before the HARM missiles arrived and were neutralized without having fired. With air defense suppression complete, the strike package descended from altitude at 12:06 a.m. 41 aircraft. A mixed complement of Super Hornets carrying GBU 31 JDAM precision-guided bombs, AGM-154C, JSOW standoff glide munitions, and AGM-158B JASSM-ER cruise missiles with penetrating warheads designed for hardened targets. The 3 launch sites were not hardened in the traditional sense. They were not underground facilities or reinforced concrete bunkers. They were prepared field positions, engineered for rapid occupancy and rapid departure, because the IRGC Aerospace Force understood that a fixed, identifiable missile launch site has a life expectancy measured in hours once it has been used. Their doctrine called for launch and displace, fire the missiles, collapse the equipment, move before the response arrives. The calculation was sound. The timing was wrong. The response had arrived before they had finished collapsing the equipment. The targeting imagery from the Space Force satellite, updated every 90 seconds throughout the engagement, had tracked the launcher vehicles at all 3 sites. 2 of the 4 launcher vehicles at the northern Khuzestan site had begun moving at 11:52 p.m., 5 minutes after launch, 3 minutes before the last intercept was confirmed. They had traveled 1.4 miles northeast along a prepared route toward a pre-surveilled dispersal area. The targeting package updated automatically. The JASSM-ER assigned to those two vehicles acquired their updated coordinates at 12:01 a.m. during its terminal flight phase and adjusted course. Both vehicles were rendered total losses of asset at 12:08 a.m., 1.7 miles from where they had been when the missiles were fired. The remaining equipment at all three sites, the ground support vehicles, the propellant handling equipment, the mobile command posts, the communications infrastructure, the pre-positioned reload missiles that represented the IRGC Aerospace Force's second strike capacity in this operational theater, was engaged systematically between 12:06 a.m. and 12:19 a.m. 13 minutes. 3 launch sites. Comprehensive destruction of the IRGC Aerospace Force's anti-ship ballistic missile capability in the Arabian Sea operational theater. The cost accounting of the operation, completed in the post-strike assessment filed at 12:31 a.m., was not expressed in dollars. It was expressed in capacity. The IRGC Aerospace Force had spent approximately 4 years and an estimated $2 billion in procurement, infrastructure, and training, developing and fielding the anti-carrier ballistic missile capability that had been brought to bear at 11:47 p.m. The missile inventory expended in the strike, 13 Khalij Fars missiles at an estimated unit cost of $12 to $15 million each, represented a significant fraction of the total production run. The launcher vehicles destroyed or rendered inoperable numbered 6 of an estimated 12 in the operational theater. The command and communications infrastructure supporting the Bandar Abbas launch complex, including the targeting and coordination network that had taken 30 months to construct and integrate, was assessed as non-recoverable without a reconstruction program measured in years rather than months. The IRGC Aerospace Force would retain anti-ship ballistic missile capability, inventory elsewhere in the country, production lines not addressed by the strike package, but the specific operational formation that had been positioned to threaten carrier strike group operations in the northern Arabian Sea had been removed from the battle space comprehensively and, for the foreseeable operational planning horizon, permanently. At 12:23 a.m., the strike package lead transmitted the post-strike assessment to the Lincoln's Combat Information Center. All assigned aim points engaged. All primary targets confirmed as total losses of asset or rendered inoperable. No aircraft lost. No battle damage to any aircraft in the package. The Lincoln's air boss began coordinating recovery operations. The first aircraft landed aboard at 12:41 a.m., its tailhook catching the 3-wire at 22 knots of relative wind over the angled deck. The deceleration measured in fractions of a second, the aircraft going from 150 knots to 0 in the length of a football field. The pilot climbed down from the cockpit. The deck crew moved to refuel and rearm. The machinery of the carrier strike group absorbed the completed operation and continued turning. In the northern Arabian Sea, the water was the same temperature it had been at 11:47 p.m. The stars were the same. The carrier was still making 22 knots into a light headwind, its flight deck now lit with the orange glow of deck crew activity, its catapults warming, its magazine elevators moving ordnance toward the deck in preparation for the next cycle. In the debris field 81 miles above the Earth's surface, the scattered components of 2 Khalij Fars missiles were completing their re-entry, burning in the upper atmosphere in trails of ionized gas that no one on the surface could see. Below, in the waters of the northern Arabian Sea, there was nothing. No wreckage. No evidence that 13 missiles had been fired at the most powerful naval formation in human history, and had found nothing but intercept geometry and the patience of a system that had been ready before they left the ground. The cost of certainty, when certainty is mistaken for capability, is always paid in full.